So I'm going to give a bit of an introduction to this panel because it's a little bit specific and technical. And for those of you who do not work in the field in explorations or in the mines, I would like to take a moment to explain this topic. It's actually changed since the publication, and I'll take responsibility for that. So it's about the value of real-time data, and can we afford to continue to do business without it? So with big data and Internet of Things becoming a part of daily life in mineral exploration and mines across the globe, and with sensor-based information, field-based instrumentation, artificial intelligence, and machine learning, and growing demands to find and expand ore deposits in more challenging settings and in a shorter time frame, the industry looks for better ways to operate and make decisions. Increased collaboration between data capture, modeling, sensor, and instrument companies is moving the industry closer to the reality of real-time information. Real-time information refers to data that is available as it is acquired. In an exploration context, for example, we take the testing to the field and acquire data sets there. So we can take a portable instrument, for example, and determine the quantity of copper, silver, or pathfinders for precious metals in real time in the field. We can also detect minerals in 5 to 15 seconds to help guide us in exploration. We can use this information to take more samples in a more valuable location or to make important real-time drilling decisions, such as whether to continue or stop a drill hole. We could be handling less barren material and shortening timelines, thus putting the same dollars to work on higher value material and vectoring to better exploration results. People are becoming accustomed to instant information in their lives, opening the door to human expectations for information access in daily life, and it will be so in mineral exploration and mining. Real-time data will become an important component to an effective exploration strategy, just as it is to have boots on the ground, a quality exploration team, and joint venture collaboration. In collecting the hard data of exploration, we look to reduce overall risk and not increase it. So why do we not push to incorporate valuable, relevant, more immediate data sets? I'd like to introduce you to the panel. First, we have Antoine Caté, a structural geology consultant at SRK Toronto. We have Danté Águilar Casillas, founder and director of Geotech and Exploration Support. We have Lynda Bloom, president of Analytical Solutions. And finally, Ben Pullinger, senior VP of Geology at Excellon Resources. Thank you all for participating. So for each question, I'll sometimes give a little bit of background so that we're all on the same page. So we sample soils and rock in the field as a key component of an exploration program to better vector to a discovery and understand the mineral potential of a project before applying more costly and deeper methods of analysis, such as drilling, etc. The quantity of spacing and samples are limited based on a particular budget. So we can use the real-time information generated from portable instruments to infill our sample spacing immediately, and to use the geochemical or mineral data, for example, to determine areas of interest and to increase the resolution of exploration information. So I'm going to ask the panel, given these time and cost-saving benefits, why do you feel this methodology is not yet widely adopted? Who would like to start? Lynda?
Hello. My background is everything from exploration, geochemistry, to lab work, to running junior mining companies. And speed is really important. And also the whole concept of being able to do things very cost effectively. We have less and less money available. You'll hear in the next panel, I think, is on financing. And also, somebody else mentioned earlier today, depletion of resources. We need to be able to do things just in general more effectively and more efficiently. So doing things in the field is really helpful, especially, I don't know, in Northern Canada right now, turnaround times at some of the commercial labs are 5 and 6 weeks, and that's about the length of our summer season. So that's not going to work out very well if you want to do any follow-up. So the field techniques are great. The one thing that is we have to remember is the whole concept of something called fit for purpose. So a lot of the hand portable methods at the current time are good for very small samples, and that can be excellent for getting detailed analysis. In other applications, we need to make sure we have things like representative samples. It's achievable, but sometimes people like to miss that step.
Anybody else want to make a comment?
Yeah, I think to add on what Lynda's saying, I think it's really important to understand kind of the problem that you're looking to solve before you adopt any technology. In the case of using handheld XRF or something for soil geochemistry, where you're looking at relative as opposed to absolute numbers, it's a very important and another really cool tool to add into the toolkit. However, when you move down the path to get into something that you have to have absolutes, I think the technology is just not quite there yet.
So, okay, as everyone is speaking in English, I'm going to try in English. So, well, before to answer the question, I would like to share with you how was my experience according with the technology in my professional life, because it's very accord with the topic that we are talking about. So I remember when I prepared my thesis in the beginning of my career, everything was made in the paper was made by hand. So maps, document, everything. So, and I remember my boss told me, probably with different vision, he recommended me to use the computer we have in the mine. It was really, really funny because we have just one computer and one IT guy. So when I tried to transfer all this data to digital, I start to type the document, and the IT guy told me, be careful with this technology because it's very sensitive. So I was scared. So fortunately, I have the opportunity to change in another company, and I make the map in the field, I log the core, everything by hand, and when I show this information to my boss, he just smiles and says, Danté, in this mine, we use just technology. You need to show me all of this information in digital. So and probably was key for me to make difference in my life, because according with this experience, I think I was lucky because I have the opportunity to balance between the technology and the traditional geology. So right now we are going to talk about different technology in exploration, like we are using in exploration. So I really believe in the technology. I think we can use different portable equipment to measure the grade of the gold. But for me, it's important always to balance between this technology and the geology and the traditional geology. So actually, it's part of my concept. I think we can take data in the field, we can improve the information, we can be fast with the process, but again, we need to be in the field. So.
To answer the question, why don't we? Why do we tend not to accept these new technologies? I think it requires effort to accept new technologies. It requires time. It requires money. And when you're in a project and things are seemingly running well, you don't necessarily want to take the time and spend the money on these new technologies. And usually it's when it's too late, when you realize that you've done something wrong, that there is a problem, that you inquire, well, what are the solutions? What can I use? What are these tools I can use? And usually it's too late and it's not going to solve your problem. So that's maybe one of the reasons we tend not to use these new technologies, is because we don't understand initially the value that they can bring if we start using them early in a project.
That's right, and it's very important to understand what you want out of the information or the technology that you're using, but also because these technologies collect information, a lot of information, very quickly, you have to do some controls very early on and approach it from a more systematic. Yeah.
So I think that's a really good point, because when we talk about adopting new technologies, it may not have the effect that we want because we haven't changed the workflows. So I think to your point, right, you have to think about how I'm going to implement this. It's one thing to acquire the data quickly, but then how do I put it on a map, and how do I interpret, and how do I actually process the information? So it can be feel quite threatening, because we're actually talking about changing people's jobs.
So let's talk about that. Let's talk about multidisciplinary data sets and the combination of that, and what are our current limitations in the industry today. Would anybody want to comment on that?
Yeah, I'll jump in and try on this one. I think one of the first things to talk about is, when you get into big data sets and you get into a multidisciplinary approach, it's having the training and the people that understand what that is, that the controls are in place, that the methodology is correct, and that you understand kind of like what the objective and the outcomes are. And I think that's something that feeds back into our conversation, or the earlier point, is that often early adoption is a high cost at entry point. So it's not easy for everybody to get in there. And then it takes a long time for that training, for that research and development, those research and development dollars to filter through, where it becomes more accessible. There's more people who understand how it works, and there's more people out there that understand how to integrate that data.
So actually, I think that the technology definitely help to take a better decision every day, help us to do our job faster. But one of the risks I see is, and actually with the new generation that I call it millennials, they born with the technology. But we have advantage with them, and it's part of the challenge for us with them, is to teach them that it's important to use the technology, but always to balance with the information we see in the field. So for this reason, I think part of the risk I see with the technology is we are going to generate more information. So if you review the data we obtain every day in the mines, we have a bunch of data. So, but one of the big problems we have right now is the analysis of the data. So normally the operations or some exploration are focused in the daily results. They are looking for gold or silver according with the metals they process. So, and they forget to analyze the rest of the data. So we have millions of information there that we need to analyze, and probably we will obtain more information, or we can discover another mine in the same district. So,
if I might jump on that, actually in this data there's also the point of the purpose of the data. In the same data set, for example, hyperspectral data or even geochemistry, different people will want different things from this data. A geologist will want to know where to do the next drill hole. A geotechnician will want to know if this specific rock will have an impact on slope stability. And the geometallurgist, we want to know what's going to happen with this rock when it's going to get into the mill. And with these new technologies, such as hyperspectral, rock physical properties measurements, with one data set, you can extract different type of informations that can be interpreted and translated into the language of all these different peoples. And when you compare that to, for example, what we're doing everywhere, which is, for example, geological descriptions, well, when a geologist makes descriptions, it's usually useless for a geotechnician or a geometallurgist to use at the end of the day. So this type of data can really improve the workflow that we currently have.
Lynda?
So I think one of the things Ben was talking about was actually combining data sets from like early stage geophysics, whether it's the geophysics or the geochemistry or the drill holes. And I found it very interesting, the Canadian Mining Innovation Council had a project called the Footprints Project. I was on that board, and they spent $10 million over 5 years, not to alarm anybody, but they looked at 3 different commodities. They collected a lot of information, and the next step was data integration. And how are we going to do that? And they implemented quite a bit of machine learning, and the outcome was some people were happy with it, and some people weren't. I wanted to point out it's complicated, right? It's not a straightforward thing. These were some of the best minds at the top-notch research institutes in Canada, and that's what they learned. It's possible, but it takes a lot of data processing, to get all these different kinds of data sets into the same, in a suitable format that you could apply something like machine learning. So it's really exciting because we're just on the cusp of probably making major breakthroughs on some of this.
Okay, Ben?
Yeah, and then just to bring it back to like the concept and the discussion around real-time data, I mean, it's something that for quite a few years now, as Lynda said, I've been pretty excited about it. It's something that we've been able to bring in to make even though there are these large complex data sets that are coming out of it, there's actually been simplicity in it as well in terms of being able to use real-time data to make decisions between something that's ore and waste, something that goes to the mill and something that gets put on a stockpile, or in terms of soil geochemistry where you understand what you're getting out of it and you can condition your data understanding what is anomalous versus what is not. So there really is a lot of potential for this, and really excited to see where it goes as we continue to push these technologies and try them and see them getting better.
So I think it's important to use the technology, because I know companies that they prefer to drill without any maps of geology, no geochemistry, nothing. So they take the risks, and I think it's more expensive to drill than to use the technology. I think that if we use the information that the companies has, I think it's enough to take a better decisions. Obviously, as a geologist, we should use different filters before to drill, make alteration maps, structural maps, geochemistry. So we should have all of these filters before to use the drilling. And if we want to use all of these filters, we should use, obviously, technology.
Yeah, it's actually a very good point that by not using these technologies, we can lose a lot of money. And one good example is the status quo that we have right now, to wait several weeks and even several months for the assays to come back once you have drilled a hole. And these assays are necessary to know if you want to continue drilling or what's the location of the next drill hole, but you won't have them until 1 month, several months. So you are making a decisions without this information, and with information that you collect while drilling, you'll be able to have more educated and more robust decisions at the end of the process.
And on that subject, is there any advantage to waiting weeks? After you collect the data and waiting weeks to, why do we do it?
I think we do it because that's what we're used to, and because in terms of what we report, I think every time I've ever seen anybody report something to the public that's come from a handheld XRF, I've always cringed. Whereas it's accepted that the results from the lab are more infallible or more absolute than new technologies or new handheld stuff, and that's what we report on, and that's what we're measured upon. So I think that's typically what people go to. Backing up though, again, it's fit for purpose, as Lynda said, and it's about using the right tools. And adding to what Danté said, there's no silver bullet for exploration. It's about selecting the most appropriate tools that give you the best answer in the shortest amount of time, that cost the least amount of money to increase the probability for success. I think that's a bit of a mouthful, but I think that's kind of the point.
It's interesting, right? Because so Antoine is saying we have a lot of tools available to us, but for someone who also works with people to develop resource estimates, at the end of the day, you will also send your samples to the lab for the assays. And one of the reasons for that is sample representativity. So it's we get, I think we were discussing before, we all really believe in the applications of different technologies, and also that we don't end up, every once in a while the industry has gotten excited about certain technologies, and there's been unequivocal adoption, which has also not worked for everybody, and then nobody wants to try anything. We really want everybody to try technologies. We really want people to think about the science behind it and also what's going to work for their applications. So you can't use some of these handheld devices which only give you a surface reading to give you the grade, and it would be inappropriate to usually put those in some kind of a press release.
Yeah, we don't want to start a misunderstanding that we're trying to replace that. Is just having more information sooner so you can make those decisions.
No, I am completely agree with Lynda. So we should use the portable equipment just to have an idea or to take decision every day. But if we want to build a mine, definitely we need a certification of the labs. So it's better to wait for a couple of months if it's necessary. Because when we open a mine, finally we are going to correlate this data with the production data, and we are going to same the set methodology of the lab. So that's the big challenge we have when we are in operations. If we really want to feel confident with the information, we should use the same information we have in the market. And in this case, is the labs, because they improve also the methodologies, they improve the technology as well. So that's why it's better to use this kind of labs in projects or mines.
Perfect.
So,
Okay.
Cindy, can I just say one more thing about that? I've been thinking about this, is that if we take all these readings ourselves, we also have to take the responsibility for the equipment to be calibrated properly and reported properly and all those things. What we've been doing historically is pushing all that responsibility onto, say, commercial labs or metallurgical labs, which is very appropriate. But now if we want to do some of this work ourselves, we do need to understand that we are the lab. So.
Yeah, that's right. Safe, responsible use of the technology. Absolutely. Okay. And so we're discussing drilling, and much of the motivation for using some of this technology is centered around that ultimate goal and taking those samples. So drilling is becoming more expensive with the need to drill deeper and in more difficult ground. And we need to incorporate more intelligence into this process as we drill. So we know that in real time as we drill, information from drilling metrics, so you've probably heard about measurement while drilling, can be used to draw parallels to ground conditions and rock properties, things like down-hole gamma. Instruments can produce real-time information to tell us if the drill hole is approaching or potentially within or through a mineralized zone. So what advantage do we have to not employing these available technologies? So is there a disadvantage to using them? I mean, how do we, I mean, we've sort of touched on this, but clearly there must be some reason why we're not using it.
The cost.
Right.
I spend a lot of time having to drill holes or tell people to drill holes. And this is actually something that I'm really excited about, is the opportunity to get the same amount of data from one drill hole as you can get from 3 or 4, to get that kind of like, I think it's, I'm not sure what the right word is here, but it's something that the industry has been looking for a long time, is that ability to link geochemical data to rock properties, to geophysical data, and all do it in a short amount of time is going to be a potential game changer. However, it's still not widely available, it's still very expensive, and it's still not widely understood, and it's going to take a while for us to adopt these kind of technologies. And like, going back to Lynda's point right now, I'm very excited because I feel, in this cycle that we are on the cusp of making some of these changes that allow us to really squeeze the most out of these drill holes. These drill holes are expensive, they become the library for every project, and we don't often get as much data out of them as we need to or should, especially in the context of, if we make a discovery, this might one day become a mine, so why not use as much of that data as you can to prepare yourself for that eventuality?
Danté, any comment?
Yes, I have the idea if you have more data, you will take more decisions. So definitely, this kind of technology help, but you need to balance between the cost you have in your exploration. And again, I mentioned before, we have enough data in the files, and we never touch them. So that's why it's a risk to have more information, and if we don't have the capacity to analyze this information, we are going to spend more money, and finally the results is going to be the same.
And then, there's also the point of quality control and what happens when you have drilled the core and you come back to the data a few years later. It's hard to have actual quality control on geologist descriptions, but if you have hard data that has been collected while drilling, so for example, just as simple as core pictures, nicely done high-quality core pictures or hyperspectral images, rock physical properties, someone can come back a few years after and see, oh, okay, the geologist has described this type of rock, and indeed the data agrees with that, or the data doesn't agree with that, and you have hard data that supports the quality of what you're looking at, and you don't have to go back to the core, that's probably lost anyway already, and relog everything.
I think I really like that point, and I just working with another client who is doing another re-logging project of the 50,000 meters of core they have, and it would be nice to think that if we had more data, I'm not saying it would always be done right the first time because we change our geological models and our interpretations, but these are really costly projects and really time-consuming. It'd be nice to see us have more confidence in our geological interpretations and the stratigraphic controls on mineralization earlier in a project.
And the math can be done. Fairly quickly. Would you rather spend upfront $5 more per meter of core to acquire some data, and then not have to pay for removing the core, relogging the core, redo an entire database? Well, of course, spending these $5 more at the beginning is totally worth it.
And I think that's kind of also the most exciting thing is that once you have that data, once you have the technology available, and then the industry learns and we get training, and we are able to take a multidisciplinary approach to all this and develop a much more scientific approach that moves away from qualitative analysis, which the industry and geology has relied on since the dawn of geology, to quantitative analysis, which really puts geology front and center again in your decision-making process, because you can actually make quantitative numerical models based on the hard data that you're getting from this new technology. And I think that's the evolution that's going to be really exciting. And the onus then falls on the training and the capability and the abilities of these geologists, of geoscientists, to take a multidisciplinary approach and actually make the most of this data.
Yeah, and to drill a bit more on the idea of logging. Later, drill holes are logged for such things as structure and minerals and all sorts of things. But it's largely through interpretation of the geologist or geotech at hand. So this is often not repeatable nor objective. This is the argument I'd like to make. Leaving the logging to be done many times over and sometimes incorrectly. So sometimes, core can be logged 10 times over in a project. I don't know if, some people here are aware of that. Do you feel technologies such as the handheld or other technologies or downhole technologies for in-field geochemistry analysis and near-infrared, et cetera, in advance of, not in replacement of, laboratory geochemical or mineral analysis could reduce the need to handle the core to just once or twice instead of relogging multiple times? And before we answer it, I would just want to say, we talk about the cost of the instrumentation, but we don't really talk about the cost of not using it. So, this another thing. So, what do you think?
So I think if we back to the basic concepts of geology, we can save money, and probably it's not necessary to use the technology. As Lynda says, it's not possible to back again to relog 100 or 1,000 of meters of core if we do the geology correct, we can save money. Obviously, if we have some technology that can help to take a better decisions before to drill or to expend a lot of money in the drilling program, we need to do that. So I'm not opposite of the technology. Actually, if we have more data, we will obtain more positive results.
And in your experience, Danté, how far behind are we in logging core in a drilling program on average?
Per day? Per
Yeah. Well, I don't know, like, is it days, weeks? Sometimes?
Well, it depends, but every day we try. Well, it's really funny also, and it's interesting question, because the different companies has different necessities. So many of them request to log fast, but I not completely agree with that. So the logging needs to expand some specific process. So it's hard to say I need to log many meters per day. So for me, the quality is the key. So because again, if we have some mistakes in this process, we need to back again to relog and expend more money.
And there are several reasons why we would need some relogging. It can be because, for example, geotechnical work has not been done properly at the very beginning, and because the geologists are not geotechnicians, and someone else will have to take back the core and properly log all the fractures. And there are technologies already out there, for example, in the oil and gas industry, to automatically log fractures using downhole imagery. And it's out there, and once it's been done, well, you can reuse it for whatever purpose, and you don't have to pull the core again. And these are standards in other industries, such as the oil and gas industries, and there are no reasons why this would not be a standard in our own industry.
I mean, and two, can you not calibrate the geotech or the geologist as well in using some other data sets to help them with the interpretation and logging core? Does it not reduce the learning curve to some point? If we use the portal?
I do think sometimes one of the advantages is, I'm thinking about multi-drill programs. So there are people running 10 drills, but that means you might have 20 geologists on staff trying to log core, and it is very subjective. It's what you see. Being able to describe that systematically is difficult. So we are talking about, we've already made huge leaps and bounds. Very few people, I like to think, are still handwriting all of their geological logs. Okay, well, we still find people. But there's so many tools in terms of acquiring that information very systematically. And that's one of the things that probably leads to better overall geological interpretations when we can get everyone describing the rocks the same way.
Yeah, I think it's a combination of quality and quantity and then practicality. A lot of people tend to push quantity, and I agree with Danté that quality is important, and that again goes back to training, understanding what your problem is, what problem you're trying to solve by logging, and making sure you're logging the relative features and you're at least getting that right. And then your data is cleaned, properly QA, QC'd, and conditioned before it goes into the database. The other thing is some of this technology, as much as I'd love to use it, it's really difficult to get to some of the places that we work. We often work in remote places that require stuff to move across borders, require dealing with customs and all the frustration that comes along with that. So practicality comes into it as well. So I think the more that the industry starts to acknowledge and adopt this stuff, the more available it will become, and ultimately the better the data will be. And I think that's going to be a few years down the road before we see a lot more of this stuff being more widely used.
So actually, in my last experience I have was very interesting, because we normally log with the traditional method in paper. Everything was made in paper. But when we translate all of this data to the digital, we make a lot of mistakes in this process, typing and all of this stuff. But one of my main challenge for me was to convince the old geologists to use the technology. But when they were convinced, we obtained very positive results, because they had experience to log and they used appropriated the technology. Again, this is the balance we need to have. And what's great because they help with the new people, with the junior, to apply the same methodology, and we obtain very positive results.
I think that's also really interesting. It's not just training old people, it's training young people and rethinking what we have to do at universities. And it's a problem, I think, around the world, but it's also just making sure we are giving geologists the skills that they haven't actually had in their programs before. So a little bit more math, I'm sorry to say, maybe even some statistics, and IT training. You know, it's one thing to teach geologists to recognize different minerals, but that may not be always the focus of their job in the future.
And I would even say basic knowledge of programming would be really useful for geologists in the future. But there's an issue here, and I don't know if there's a solution, is that we still need core geological knowledge as well. A geologist needs to know what structural geology, he needs to know sedimentology and all of these fields. So in the future, geologists will need to have this core knowledge and have some specialties, for example, in mathematical geology or in programming, things like that. Yeah, I'm not sure there are solutions to this issue.
Yeah, I almost think we're getting to the point where we're spoiled with software. I remember adopting software earlier on in my career, and you actually had to know how to write queries and code into the software to get what you wanted out of it. Whereas everything now is push button. So I agree, understanding what's going on behind the button that you're pushing is actually a really important part of the process, is to understanding what the results you're getting are.
Okay, great. I think we'll move on to some audience questions. Alexis from Hexagon asks, with all the different technologies being implemented, how do you plan to integrate all the data sets in order to avoid data silos? Second question, how important would you consider that mobility of the data is going to be? So I guess we could start with how do you plan to integrate all the data in order to avoid data silos?
Yeah, I can maybe answer to this question. The issue is that all these different tools are proposed by different companies who will propose different ways to publish the results. And what's going to be needed are open API, which means that you need to have your data openly readable by different softwares to make open source available to any software creator the way your data is published. And that's an issue I think we have a lot, especially in the mine industry, is that we use a lot of proprietary format for data. Geophysical data can be only read by one software and not by one other. It happens a lot. And that's a problem we're going to have to solve, because all of this data, there's going to be geochemical data, geophysical data, hyperspectral data. They have different formats that needs to be read by different types of softwares, and we need to integrate that into a single workflow. And the main issue will be this API and the way to discuss between the different softwares.
You can see this at mine sites also. The Internet of Things is a hot topic. And it has to be industry-driven. We have to demand it from our suppliers. Otherwise, it doesn't happen. You're starting to see more open transfer of sharing of data between systems at a mine site. And that's going to also be a game changer at the mine sites. Exploration, we're not spending quite as much money. People don't listen to us quite as well. But this is what we have to demand.
And there are initiatives for this subject. There is the open mining format, which is an international initiative to have a common format for different types of data. So it's coming and it's going to happen.
Yeah, I'm glad you brought that up, because that's one of the points I was going to make as well. But again, we failed to mention one of the new kind of core competencies of anybody in the geoscience field these days is strong data management skills. Understanding how databases work, understanding how to query them, understanding how to work with that data, and then get it into one comprehensive data set that can be used universally and can be integrated into other data sets through, there's some pretty cool technology out there and software out there that allows you to start to bring these things together. And I think we are starting to see, especially with the OMF format, starting to see more collaboration through the industry in terms of trying to bring these things together. So it's all kind of like gathering momentum.
So, and I think in Mexico is really special because we have very rich information, public information that we can analyze through GIS. So we have public information, and there are geophysics, geochemistry, and everything. So we can cover big areas. We can select some specific targets just using this information. So it's very cheap in Mexico to use this data, and for me, it's very rich information that we have in Consejo Servicio Geológico Mexicano, something like that.
Okay. I have one more question. Somebody's asking, Juan Jose, Vega Measurement Mexico, is asking about using satellites to do exploration, and how do you do that? Are you currently doing that? Maybe Ben, do you want to start with that?
It's quite topical. It's something that we do a fair bit of, especially when approaching a regional exploration project. There's a couple different kinds of satellites out there that take different kinds of imagery and that you can use. There's algorithms out there that you can use to kind of like filter through and look for different mineral occurrences. We're getting a little technological here, but really it gives you a good first pass and another tool in your quiver, so to speak, in terms of like quickly identifying more prospective areas over less prospective areas in kind of like big land packages that you can then send your field geologists up to go follow up and be more efficient with your time. It's definitely an application for them. They seem to work quite well when they're used correctly. And it's just really like a good, another layer to add to your methodological approach towards getting into the right areas to increase your probability of finding something.
So I think in my case, it's very important information that we can use for exploration. But again, for example, I have one of the projects I reviewed recently. We identify some specific alteration in the field. And when we correlate this data with the satellite image, they provide us very nice signature. So if we have, or we know, or we match this alteration with the technology, then finally you can find different targets in big areas.
But I mean, just to add to that, one of the best exploration tools that I've found, which I don't think was unintentional, but one of the best exploration tools that I've seen come out in the last 10 years has been Google Earth. Like constant updating of satellite imageries and high-resolution satellite imagery that allows you to go and like use that as a base map or go and like zoom into areas that you're interested in before you even set foot on the ground, I think has been a huge help to the industry.
And a lot of this satellite data is available for free, so anyone can use them.
Okay, well, thank you very much. We're going to close the panel off with a bit of a takeaway summary. Oh, yeah? Sure. How much do you use LiDAR for exploration?
I think LiDAR is a great tool when you don't have surface exposure in cover terrains and jungles and stuff like that. I've seen it used. I've used it very little on my own, but I've seen it used and turn out some really good results. And I think it's kind of like growing in its applicability, especially in areas, and especially as we push into frontier areas that we don't have good base maps, that we don't have good satellite imagery because of tropical cover and stuff like that. But I think it's another one of those like very many tools that you need to like assess the applicability for your situation.
So, but I think it depends on the project. For example, we recently analyzed a project that was very flat. So we were looking for some trends or fractures. So we use LiDAR in order to identify some specific deformation in flat areas and can help a lot. So we use it.
All right. So we know there's a lot of upper management and decision makers in the audience. And so we were really pleased to bring this panel to you. And we want to say thank you to the group for the Mexico Mining Forum 2019 for allowing us to do this and making this possible. And takeaways being, with regard to adoption of technology maybe and real-time data, we've come up with the idea that there's maybe a higher cost of initial adoption maybe we're not also balancing that with the real costs of not using the information in real time. Applying a fit-for-purpose approach, strong information management skills, and cooperation with the universities to provide ready students for the new world. Logistical challenges of implementation, the need to have checks and balances in the application of the technology and collecting data very quickly. And let's see what else. I think that was pretty much it. Any addition? No?
Thank you.
Okay.
Thank you.
We have zeros. We're done. Thank you very much.